you. So our knowledge-based series of webinars is really about sharing knowledge, sharing our members' world-leading knowledge, and really to share it with the industry so that it's innate, so that you can use this knowledge-based resource for anyone who's interested in marine spill response. And we want to basically share it so that it can be commented upon, and it should enable knowledge across the industry to be increased. Over time, we hope this will become a place where those involved or interested in spill response may come and to inquire, increase their knowledge, understand what good looks like so that they can work more safely, being compliant with the relevant legislation, and deliver a better service to their customers. So we've got 10 knowledge-based webinars in 2021, and I have a feeling, based on the feedback of last week, and I'm sure the feedback from this will be positive, is that we may end up running more of these. They will all be kept and shared. They will end up on our website in our knowledge base. Our new website is on its way, and within that section you'll find a heading called knowledge base. And that will be your gateway into this body of knowledge. And we will add other things to it which we see which might be relevant to disseminating knowledge across the industry. You'll also be able to read Spill Alert, which is our association's quarterly magazine. You can follow that, go to the website, click on the link, and that will take you to where that is, and that you can read online. And that has within it examples of best practice. And obviously many of you will have seen our LinkedIn feed. Make sure you follow us, because that's always good for your ratings and things like that. So basically this one is on marine booms. The next one is not until the 24th of March, and that's to do with absorbents, what they are, how to use them. And that will be led by Darcy, and there will obviously be a responder who can talk about the practical aspects of that. And there will be various others rolling on. I would highlight a change to an addition to the programme. We do have we do have another Wakashio presentation coming up, which is going to be quite exciting. Watch out on LinkedIn for that. We've been very fortunate in that we are able to, Polyeco, who've been the spill responder, and have done most of the spill cleanup from the Wakashio incident, have agreed to cooperate on 2 webinars with us. The first is actually on the 24th, not the 27th, as that says. That's my mistake, so I'll beat myself up later. But the 27th, that's going to be on the 24th, and it will kick off at 12 o'clock midday, and that's because of the time zone difference between us and Mauritius. And that will be really interesting. It will give us we'll update where we are. Polyeco will then talk about how they did the initial cleanup, i.e. the product which is in the water, and how they effectively cleared that up, dealt with the waste disposal aspects of it. And I think we're really chuffed that they are going to cooperate with that. And then later on, we're going to do one to do with more of the remediation aspects of the Wakashio. And sandwiched in between, we're hoping to do one on plastic pollution, which will bring in a number of parties together to talk about that. Because that's obviously a big issue in the industry, big issue around the world at the moment. So really I want to introduce our speakers today. We've got Paul Rayner from Vicoma. Vicoma are a well-known, well-established British manufacturer of marine spill response equipment. Paul Rayner is their sales director, and he's worked with Vicoma throughout most of his working life. But he's also been involved in incidents around the world and supported customers with incidents around the world. So he brings a strong body of experience and knowledge to this presentation. So he's going to talk about it as a manufacturer and as a developer of innovative equipment. Mark Shepherd's going to give the responder input. Mark, again, has worked in this industry for a long time. He started his career in the Merchant Navy, where he was particularly involved in firefighting and damage control. That interest for the rather dangerous side of life obviously caused him to get involved in spill response. And he's worked for a number of different companies, from OSRL, ENI, BP, Braemar, and he's currently the emergency response manager for NRC based up in Aberdeen. So they're your speakers. Do ask questions, use the chat facility, and I'll make sure that the questions that you raise will be answered by our speakers. And without further ado, I'd like to unshare my screen. Paul will share with his, and he'll share some of his knowledge about marine booms with you. How are you getting on, Paul?
Yeah, it's actually not. It's just saying you've disabled, unfortunately.
I haven't, have I? Sorry. Beg your pardon. You should be clear now.
Excellent. So hopefully you can all see that. Thank you very much, Mark. So what I'd like to do this afternoon is really a sort of a brief presentation, which is really going to cover some of the aspects of what oil spill booms are. So the presentation is going to be a little bit of a sales pitch on Vicoma, who we are, what we do, and then it's going to specifically go into oil spill booms, so the types of booms, the applications, very much a pros and cons of the different types of booms, different types of materials, a segment on connectors, and then a little bit on storage and repair. And then I hand over to Mark, and he'll talk about it from the responders' point of view. So as many of you will know, Vicoma was established in 1967 and by BP following the Torrey Canyon incident. We have a factory down on the Isle of Wight, and as Mark said, we're a proud UK design and manufacturer. So we have our whole team based down on the island, and we build everything there and then supply out all around the world. Myself, Paul Rayner, Sales Director, so I've been with the company, it'll be 30 years next year, and throughout that time I've worked in many departments with a lot of time spent within sales, and as Mark said, spent a lot of time traveling around the world. Not directly involved with incidents, but a lot of time spent with the responders and people who are actually dealing with oil spills. So a big part of my job and my teams has been to understand the issues that responders have and then feed it back into our development program. So we're an ISO 9001 company, had the joy of going through the latest version of accreditation, 2015. And importantly, that covers everything within our business. So not just the sales and development, but the manufacture, the design, the installation, commissioning and training. So important to look at all those aspects being covered under the ISO 9001 quality umbrella. Vicoma prides itself really on three core values: quality, reliability, and innovation. So really quality products that will work when they need to. So as you all know, there's not an oil spill every day, but when it does happen, you need the equipment to work. So that's very much the sales pitch. So what I was asked to look at today was oil spill booms. And I thought if you look at the membership of UK Spill, it's very varied. So most people think of oil spill and they think of tankers, they think of offshore, they think of these major spills. But you know, there's as many spills, far more spills actually in ports and harbors, far more spills inland, you know, pipelines, rivers, lakes, industrial culverts, industrial sites. So it's not all about big offshore booms. So today's presentation, I'm really going to cover the main part of what is about containment. So I'm going to talk about different types of boom and really how I see the pros and cons and what I've had as feedback over the last 20, 30 years from responders on what are the pros and cons of the different types of boom. So typically, a good picture there, you can actually see boom being used to contain on a lovely day. Lovely spill conditions, nice calm sea, very rarely happens. So how we select booms is really important to what you're trying to achieve as a responder, how you're going to deal with that spill and what type of boom you're going to use and how you're going to use it. So if you start from the real basics of what is a boom, it really is a floating barrier that goes on the water. And the components, if you read for just about any book, will talk about some form of float. A freeboard that is obviously above the water, and a draft, which is usually the skirt below the water. And there's a plethora of different versions of what makes up these barriers. And I've seen everything from logs being used to really high-tech technical booming systems. But basically, they still have the same principles: what's above the water, what's below the water, and the principle being to stop the spill spreading and then to contain it so you can effectively use your skimming systems to recover it. So I was trying to think of what are the applications, and there are many different applications. So not only emergency response, which is generally a relatively short-term deployment, but there can be emergency response, which is a long-term deployment. So this can be short-term hours, long-term days, weeks, even months. There's also booms that are used for permanent deployment. So to permanently protect an area, either to stop a spill getting in or to stop a spill getting out. There's also land-based containment. So this is sealing off shorelines, sealing off beaches, riverbanks, etc. So you can see straight away how one boom is not going to fit all of these applications. Even down to industrial. We often supply boom systems for industrial use, for fitting into API separators in refineries and petrochemical plants, completely different to response booms. So it really is understanding what your application is. Many responders have the challenge that they actually respond to many different applications. So it's having a toolbox of different techniques, methods, and equipment, which will allow them to effectively do that. So I started listing out what I thought was the issues with boom, what really matters. And I came up with a massive list. And I'm sure as experienced responders that many of you are, you could add to this list. But there were simple things like safety, weight, ease of cleaning, ease of use. How many people do you need? How easy is it to tow? Can you anchor it? How long is it going to be deployed for? Is there going to be waves? What's the temperature going to be? And all of these factors are really key to understanding what challenges you're going to have as a responder and what sort of boom you're going to need to be able to respond to that application. And all of these things are considerations, but some of them will be important to you. So at the end of my presentation, I'll come back and it's almost an open question to the audience of what are the things that are important to you? And the likelihood is that each response, it's going to be some different things each time. So if you look at the types of boom, if you look at the terminology, there are several different types of fence booms, air-filled booms, foam-filled booms, self-inflating booms, shore sealing booms, pod booms, fire booms, debris booms, chemical resistant booms, and that's without going into things like absorbent booms. So you already have this great big list of different types of booms, but what does it really mean? I actually thought a very simple way to look at this was to look at some pros and cons. Now, this isn't just a sales director's opinion. This is very much feedback that I've had over the years from responders. People are actually using these types of booms. So I'm not going to go through all of them verbatim, but if you look at the key points, fence booms, really easy to use, really easy to deploy, low training requirement, relatively easy to clean. They won't sink because they've got foam inside. Sounds great. What are the cons? Big and bulky, can be really heavy. They have a tendency to fall over when it's windy. They're not great in wave conditions. The potential loss of oil between the floats. They can be difficult to handle and they can be rigid with poor flexibility. So some really good points, some really challenging points. So it really is weighing up what you're trying to achieve. I've seen people that have used fence boom really effectively in ports and harbours and rivers. And then I've seen people try to put fence booms out at sea. It's been windy and the fence booms literally fell over and is planing across the water and not containing any oil whatsoever. If you look at airfield booms, probably one of the biggest and best known range of booms for offshore use. So really good pros, excellent wave following, generally really good high buoyancy to weight ratio. So this means they're able to react to waves. They can be really quick to deploy. So if you take Vekoma, we have single point inflation with our high sprint boom, which allows really rapid deployment. Generally small volume, because it's air inflated buoyancy, you can store them on reels, so you can have quite a lot of boom on one reel. They're generally easy to repair. What are the cons? Generally, you need a higher training requirement. You need people who know what they're doing. There could be a risk of buoyancy loss due to puncturing. You do need mechanical inflation. They can be slower to recover. So again, it's about weighing up the different pros and cons of each boom system. And if you look at specifically around airfield booms, what are the considerations? Air pressure, for example, whether it's in PSI or bar, and it's basically, what does it mean? Low air pressure is flexible, higher air pressure is more rigid. So this is how it's going to react in a wave condition. Something that's hard and rigid is going to be difficult to move around. Something that's soft and flexible will easily move around. Considerations like chambers, one chamber or multiple chambers. This is going to give you more integrity. The types of material, the actual measurements of freeboard and draft. Operationally, what are the measurements? So I've seen many people talk about huge booms, but how big are they when they're inflated and actually in the water? I've seen tenders which state the flat width of a boom for a tender. Well, you don't use a boom when it's flat, you use it when it's inflated. The profile of the boom, smooth versus irregular, how that might affect oil loss. What sort of tension or ballast member is used and how is it fitted to the boom? What's the strength of the boom? What's the weight of the boom? How easy is it to repair? What's its abrasion resistance? If this is going to be dragged across a quayside or dragged down a pontoon, then you could well have issues with abrasion. A very common boom, particularly in the States, is foam-filled cylindrical boom, often referred to as contractor boom. So again, you look at this, really simple to use. If you go to spills, like the Macondo spill, they're worth miles and miles of this sort of boom. Really quick to deploy, no inflation, low training, higher buoyancy to weight ratio than fence booms because it's cylindrical foam, and they won't sink. What are the cons? They're big. They're bulky. Not all people use closed cell foam. I've seen wonderful fence booms and cylindrical foam filled booms with open cell foam. Open cell foam is a sponge. It gets wet, it fills with water, it sinks. They're not overly great in waves because each one of those foam billets is rigid. They can be difficult to handle. They can be heavy to use, heavy to pick up. Generally, they're lower cost fabrics because a lot of the strength goes into the tension members. So a lot of the strength from the boom comes from the tension members. So again, pros and cons. Self-inflating boom. This was really popular many years ago. When I first came into the industry, everyone was talking about self-inflating boom. Great, you can chuck it out, it inflates very quick. So again, the pros, quick to deploy, very important in a spill, generally flexible because it's air-filled, small volume. What are the cons? Maintenance. You've got all these internals inside this boom. You've got metal and plastics inside a fabric bag. They can be difficult to recover. They can be expensive and they can be easy to damage because some will have valves poking out the top. Some will have mechanical springs inside. So again, really weighing up what you're trying to achieve, the level of skill you have as responders, and how easy you can use this equipment. Shore sealing booms. So if you look at that, originally designed for that intertidal interface between the water and the land, but often used on land spills, not just for the beach where it was originally designed for many years ago. So this is excellent for intertidal areas, seals against the ground when it's low tide, and obviously floats when the water comes in. So ideal for sealing off. Some crossover for holding back water as well, for sealing off an area during operations. So very recently, a lot of Vicoma boom was used on a salvage operation where Shore Guardian boom was used to surround a vessel that was being dismantled and salvaged. So it can be used on land as well as this land-water interface. The cons, though, you need good training. You need people who know what they're doing. Once you put them out, once you filled them with water, they're not going to move unless they're floating. So you need to think about and plan how you're going to use it, where you're going to put it. Definite care needs to be taken during deployment and recovery because of abrasion. Now, these are designed to sit on the ground. So it's no good having a material that's weak and low cost that's going to wear through quickly, because you'll lose the effectiveness of that boom. There's also pod or debris booms. So this is where you come into really strong booms, often used to hold back debris as well as oil. So the pros for this, really strong, ideal for permanent deployment. They're good at withstanding debris. They're usually made of really high strength materials, good for impact, great for wear and tear, relatively easy to repair. A lot of the pods are bolted to the belting. What are the cons? Heavy, really difficult to deploy. So they're not an ideal emergency response. They can be incredibly bulky. So how are you going to pick them up? How are you going to move them? How are you going to deploy them? And can be big issues with marine growth, the same as with any permanent boom. So once a boom is deployed permanently, there is often issues where marine growth will start growing onto the boom and basically start reducing the buoyancy because of the extra weight. So I've seen permanent boom that hasn't been maintained basically starting to sink. But with all these things, again, the pros and cons, what are you trying to achieve? What's your objective? Going to touch on Fireboom really briefly. I believe it's a subject for a future webinar. So, really great publicity for firebooms during Macondo spill. So the ability to contain and dispose of the spill in one go, it can be done quickly because you're disposing with it, and it can deal with large amounts of oil. What are the cons? Costs, weather conditions, pollution, air pollution, and training again. So it's having the correct level of training. And you'll see a theme through all of these boom types. Generally, unless it's a throw it in simple fence boom or contractor boom, you do need well-trained people. And I believe Mark will cover some of the issues around training. I thought it poignant to touch on chemically resistant booms. So there's a lot of talk about HNS within OPRC. So booms that are going to be able to hold back chemicals. So I thought about trying to put a picture on this and thought the three question marks and scratching the head was probably a good way of doing it. What's the chemical? What happens with it when it mixes with the water? Is it salt water? Is it fresh water? Is it mixed with other chemicals? How diluted is it? What's it going to do to the material? So I see this as a really big challenge for the industry going forward as HNS protocols are adopted as part of OPRC legislation. What equipment are we going to use? There's a lot of equipment for land-based HNS, but marine-based, some chemicals, you can't see them. Some chemicals, you can't go anywhere near them. Some chemicals will destroy things. So it's. I think this is going to be an interesting subject over the next few years as both the legislation rolls out and the industry adapts to be able to deal with it. So if you look at all those types of boom, one of the key elements, one of the most important things is the materials that they're made of. And generally speaking, there are a couple of groups of materials. There are the sort of thermoplastics, so the PVC, polyurethane alloys, polyurethane, and then the sort of rubber products, so things like Hypalon and neoprene. Then if you go into things like pods, it's often polyethylene or polypropylene or even fiberglass. It's important to note there's a huge difference in what all of these materials are. You know, as I mentioned earlier on foam, closed cell foam versus open celled foam, rolled billets, plates, logs, granules. They're all factors you need to consider when you're actually purchasing a boom. And people will talk about, okay, I know exactly what I need. I want a cheap boom. I'm going to make it out of PVC. Nothing wrong with PVC, fantastic material. How long do you want the boom to last? What are you going to do with it afterwards? How are you going to clean it? If you've got to dispose of it, where can you dispose of it? How can you dispose of it? What's the life cost of that boom? Now, people have said to me, Vicamera is well known for neoprene booms like High Sprint, and they'll say, I can buy 2 or 3 PVC booms for that cost. And I said, yes, you can, but you've got to dispose of those 2 or 3 PVC booms, and you can still use my neoprene boom. So what's the cost of that disposal? You know, what's the cost of you replacing? What's the cost of purchase? So it's quite interesting point to understand the different types of material that are used in oil spill booms. So again, I thought useful to put in some considerations, things like weight. You know, I could make a bulletproof boom out of fiberglass. You'd never pick it up. You know, the strength, its resistance to things, quite important things for an oil spill, abrasion, oil. It's quite important to know how good it is with oil. UV, temperature, low and high. You know, low temperature, big issue with thermoplastics. High temperature, big issue with thermoplastics. Where are you going to operate? Perhaps low temperature is not an issue to you, but UV light is. If you're going to deploy for long periods of time, what is the UV breakdown likely to be causing of that material? The lifespan, how long is it going to last? And remember, a lot of the time, this is in storage. How long can you store it? What conditions are you going to store it in? How easy is it to clean? What's the issues as it ages? You know, how much will that cost to look after it? How are other pieces connected to that material? So if you think of any fabric material, as soon as I start making holes in it, as soon as I start putting bolts in it or valves in it, I actually start damaging that material. So really important to think about how items like connectors and valves are fitted into these booms, into these fabric products. And then really importantly, the thing that I think that so many people forget, that eventual disposal cost. Eventually, you've got to get rid of this. Eventually, you've got to dispose of it. You can't bury it anymore. You can't just go and burn it. A lot of it's hazardous waste. So this is an expensive process of actually disposing of these booms after use. It'd be very interesting to talk with someone like Polyeco with the Wakashio spill to understand all of those temporary makeshift booms. What do they do with them? Yeah, how do they get rid of them? What was the cost? What was the environmental impact of actually disposing of them afterwards? I then thought a useful topic to cover would have been connectors. And then I realized how complicated this was. So I started listing out connectors. Vicamera, well known for Unicom, ASTM, a US standard, quite well adopted across the world, but there's several types of ASTM connector. There's hinge and pin connector, U-bolt connector, slide bolt connector, zip connector, slotted, and on and on and on. There's also the materials of what those connectors are made of. Aluminium, stainless steel, plastic, galvanized, fiberglass, a whole plethora again of materials. So I thought I'd get some pictures, lots and lots of different types of connector, even more different types of connector. Lo and behold, they don't all fit together. So we were talking in previous webinars about standards. So ASTM in the States have tried to push these standards so that they have booms that can connect together. Only really widely adopted in the States. Even in the States, there are a plethora of different types of connector, and they do not connect together. It really is the square peg in a round hole. So really important to understand what type of connector, how that's fitted on the boom, and then how you use it. I then thought it useful to talk a little bit about storage. So everyone thinks about the oil spill boom. Well, 90% of the time it's in storage. So how are you looking after it? How are you storing that? Whether it's bags, reels, crates, stillages. So all of these things are quite important to understand when you're initially purchasing. How are you going to look after it? How are these different types of storage going to be employed for deployment and recovery of that boom? Unfortunately, in my experience, a lot of the time people do forget about it. So considerations, weight, logistics, how am I going to move that around? I've seen people say, great, I want a reel. And I say, great, where's your crane? I haven't got one of those. Well, how are you going to move it? I've got a fork truck. How are you going to take that on the beach if you need to take the reel down there? So it's really important to understand the logistics. If you're going to have bags, carrying weight for one operator, 25 kilos. No good having a boom that's 200 kilos if you're expecting people to pick it up and carry it. Training requirements, how are you going to use that? Storage when it's not in use, where are you going to put it? Is it going to be indoors? Is it temperature controlled if you've got extreme climates? And my experience, unfortunately, a lot of booms, that's how it's stored. Great big heap, not cleaned up very well, but that's expected to work next time there's a spill. I made sure that it wasn't anyone I knew, but definitely things to consider. And then sort of to wrap things up, how do you go about repairing booms? Now, we all know, no matter how well trained you are, no matter how well planned you've done things, accidents will happen. There'll be debris in the water or things will get abraded. So what are the different methods? So very typically, cold glue, like fixing a bicycle repair. Vulcanized, something Vicoma is really well known for, where we can repair the boom as strong as the original manufacturing. Mechanical seals. If you're anyone who's got a rib, you know you can actually put one of these and you clamp a seal over the hole. Hot air. Sounds easy. One of the most difficult repairs I've ever tried to do in my life. Really easy to burn a hole straight through boom. Sticky patches. You can actually repair a boom with a sticking plaster. But again, what are the considerations? Training and competency, ease of repair, longevity of repair. If you're using adhesive, what's the shelf life? Once you open that 5-litre tin and you only use half a litre of it, how long does that adhesive last after you've opened it? Can you do a repair on site at the spill site and still go on with this, dealing with the spill, or does it need to go back to the workshop? Repair versus disposal. When is it commercially viable to repair versus commercially viable to dispose? And most importantly, does the repair affect the operation of the boom itself? And this is not only the air holding, if it's air filled, but how you clean it afterwards. Are you going to actually cause more damage? So all important things to consider. And I thought as well, the other things to consider would be things like, where are you deploying? What is, again, back to that application. Deploying at sea is completely different to deploying in a swamp, completely different to an industrial area, completely different to a mangrove, completely different to a beach. If you're deploying in an area where there's going to be land involved, or it's going to drag on the bottom of the seabed, or it's shallow water, what sort of area you're deploying in? Sand, soil, mud, coral, shingle, tarmac. It could be a flooded area where you've got tarmac, but you've got lots of water. You could have areas where it's merrily floating in the water, no problem. And then as the tide goes out and recedes, you're suddenly on top of coral. And coral will rip fabric to pieces. So very important to understand what it is. So I go back to my original slide of booms, what matters. And really, it's an open question to you all to think about what's important to you. So that's the pitch from the manufacturer. What I'd like to do now is to pass over to Mark, and he's going to talk about it very much from the responders' point of view.
Thank you, Paul. I'm just going to pull my screen up, I think. Technology will let me down as usual. Right, I need to change these. Bear with me. Sorry about this, I'm having a bit of a technical issue going on here. Across there. That one across there. Right, that should do it this time. Which screen can we see?
We can see you at the moment.
All right, just me.
Just you.
What's going on with my shared screen then, Mark? Help. Share screen. Yes, share.
We've got your home page.
You got my messy desktop at the
We
moment.
got your messy desktop.
Okay, so where's my... Oh. No, I don't know what's going on. We'll have to... Mark said to me, stop, make sure you... oh, the presentation's closed down, that's why. Make sure you close everything on your desktop first, which I have done. Right, now then, let's go back. Share screen. Share. Right, hopefully.
Hey, and now if you go to slideshow, and then from the start, or from where you are. Yeah, that's it.
Have you got full screen of that, not the notes?
No, we're seeing your presenter view at the moment. We're not seeing the full screen. There you are.
Right, why is that then? How do I change screens? This isn't very good, is it?
Now just go.
Yeah, no, I want the full screen on, but I'm struggling with that. Okay. Okay, we'll have to go with the notes with the.
Just go click this.
Yeah, but there's a way to. All right. That's better, isn't it? Yeah.
That's it. That's the one.
All right. Sorry about that.
You want to get to your first slide then, Mark?
Yes.
Lovely.
Yeah. My apologies for that technology. This is the first time I've really done a webinar on this system, so you just excuse me for that. So as Mark said at the beginning, I'm Mark Shepherd. I'm the Emergency Response Manager at NRC based in Old Meldrum, Scotland. I've been involved in oil spills and emergency response for many years now, both from a response point of view and from an incident management point of view. So the intent was for me to look at following on from Paul's very in-depth presentation, which covered most of the things I want to look at, just to look at how things come from a responder's point of view and considerations. So initially, we'll have a look at of the use of booms. Paul's talked about the types and where they are, and some of the uses. So things like containment at source, often used to minimise the spread of a spill. At source. Obviously for this, you need to have hopefully the boom in place for a quick deployment and train people on site, or it'll be used in a ongoing incident such as a vessel grounding where there's either a slow steady release coming on or a potential of a release. So like I say, this really needs the equipment to be there on site and ready to deploy. The reality is that that never really happens because there's all sorts of other things going on when there's a spill happening, and getting the boom out is probably one of the latter considerations. Using booms for protection, again, a good strategy in pre-planning. If you know where your sensitivities are, get your boom out. In the event of a spill, from your modeling, you'll know the drift and direction of the spill, likely times of impact to sensitivities, shorelines and things like that. Also used for ship-to-ship transfers when there's fuel operations going on. A lot of terminals, marine terminals have it for when they're loading and unloading tankers. And we see quite a bit up in Scotland when the rigs come in for some maintenance or some repairs to be done. There's often pre-booming done in place there as well. Shoreline operations. Now, shorelines can either be a very straightforward and simple process, a nice sandy beach with no debris, nothing in the way, not too many sunbathers, and you can get a nice boom out. But the reality again is shorelines aren't always like that. They can be very complex. A lot of different types of shoreline around. So pre-planning, again, having the right boom for the right shoreline. Sandy beaches is good, but then if you've got a lot of riprap and jetties and things like that, you might need a different type of boom. And, you know, shorelines are very labor intensive. A lot of people are on there. Again, bringing more hazards and more issues. The bottom picture, you can see a lot of people on a beach, on a shoreline somewhere, a failed bit of fence boom in there, not protecting it, and it's washed up. So shorelines, a lot of considerations, and a lot of labor and time consuming. Paul touched on the use of the shore sealing boom. Really good boom when deployed correctly on the right beaches or on land now. It's a single air chamber with 2 water chambers in almost a figure of 8 configuration at the bottom. So you've got 2 water chambers at the bottom. Get it in position and then fill it up with water, and it's great. Get it in the wrong position, fill it up with water and try and move it, good luck. Likelihoods is it's not going to move without pumping all the water out or pulling the boom apart. And you'll see a bit later that that can happen. Offshore, we see quite a lot. Paul touched on that, the big booms, the neoprene airfield booms, many different types of boom. And depending on how quick you can get it out and the vessels that are available to you, it can be an effective strategy. We'll leave that one as a responder's decision. Some people have an opinion on the effectiveness of it, and others say it could be 20 to 25%, 30% effective. But it's a strategy, and it's good to get it out there. We do a lot of offshore booming, a lot of training with the offshore booms of different configurations. And, you know, I think the one thing you need with all of this is competent and trained personnel. So it's not just the crew members or the people on the back of the deck deploying the boom, but the captains or the navigators on the vessel have known how to put that in. So normally you'll deploy the boom and you'll go for one of several configurations, either a U configuration. The U configuration gives you a very wide swath width. If you deploy 200, 500 meters, 400 meters of boom, it will give you a good wide swath configuration, good encounter rates, and based on that, you know, you need 2 vessels, a main vessel to pull, a good vessel to pull it along. A lot of times vessels think they're too powerful for this kind of boom. You know, you'll see the modern standby vessels and they say, oh, we've got too much power. But they don't need to pull this at high speed. You know, we're only doing 0.7 of a knot. Once you've got the apex of that boom full, you'll either come up into a J configuration and have a skimmer on board the recovery vessel, or you'll bring a 3rd vessel into the apex to start recovery operations. The J configuration, single vessel operation, nice seal along the side of the recovery vessel as the lead vessel. Pull that up, get the J configuration, smaller swath or encounter rates than the U, but you only need 2 vessels and you can be trawling along, collecting the oil and skimming at the same time. V configuration, don't often see this in use, to be honest, because it does really rely on the 3rd vessel being a specialized vessel, which is the recovery vessel at the apex. And as you can see from the kind of bottom picture there, that has a small encounter rate, a low encounter rate. And then, like I say, you've got to have that specialist recovery vessel that the booms are attached to, and it's got a skimmer normally in the bow collecting the oil. And then we have the single sweep systems, single ship systems. These are normally a boom arm, 25 to 50 meters deployed off of one vessel, can be used for recovery and skimming at the same time. good for limited resources and smaller spills, or a lot of fragmented spills where you'll go up once a lot of the main oil's been collected out at sea, go off with a side single system and collect up the fragments of oil and recover from there. Can also be used for very small light spills off of an FRC using absorbents, or you can be an innovative fisherman using their outriggers. This was done on the Gulf of Mexico. Never seen something quite like it. It looks quite complex and tangled, but effective. Anything in an oil spill is useful. River booming. Again, pre-planning is very important when you have the potential for spills on rivers. You know, they're often faster currents, fast flowing rivers. I know the river currently opposite my house at the moment is flowing very deep and very fast at the moment as all the snow and rain we've had up here. So, you know, pre-planning for this, having tactical response plans, knowing the locations to deploy boom, access for that, and where good recovery points are. So you can use the boom to deflect the oil to an area on a bend where the water's slower, and you've got good access to get all your equipment down and recover from. Paul touched on fire boom. It is fire in situ burning is a very effective strategy. Does rely on pre-approvals a lot of the time. There was over 411 successful booms done during the Deepwater Horizon. So it is effective. And it's also a very good strategy for oil spills in ice as well, or ice conditions. So like I think Mark has said, there'll be a special session on fire booms in June, I think it is. Boom failures, these are well-known kind of things. I'm not attending this as a oil spill kind of training course, but there are many different throws, from undercuts, splashovers, mechanical failures caused by sometimes splashover, caused by pulling the boom too fast. You know, you want to be towing the boom at 0.7 of a knot maximum. Pull it any faster than that and you'll get splashovers or undercuts. You'll also get wave effect, will be splashing over, or just mechanical failures, you know, where the booms inflation booms lose a chamber, an air chamber, and it fails, or the weather has affected it. This is a couple of pictures of boom failures. You know, we talk about, Paul touched on these, of the qualities and the types of booms we use. You can see a lot of failures in booms through misuse, abrasion from rubbing up alongside of jetties, vessels, trying to pull them when they're full of water, or, you know, or even towing them too fast. One of the things I haven't really touched on, and I think it's going to be used for a later webinar, is kind of while we're talking about booms, and I've been through different types, is the newer or the active boom systems, things like the current busters and things like that. That will be covered in separate sessions. I stole one of Paul's slides, because as a responder, you know, we could say all of that's important, but I just wanted to pick up and highlight a few of Paul's thoughts on what's important, and especially when I look at kind of things from a UK and Ireland Spill Association of standards and things. So pre-planning is always important, you know, have the right plans, the right equipment, the trained people in place, the right platforms to operate off of. It's all critical to having an effective response. So making sure you've got your pre-plans right, your contingency plans are right, if appropriate, tactical response plans, training and competency programs for not just the responders, but for the frontline people that might be out there deploying it first. Vessel crews, again, critical to make sure that's happening. And also the right infrastructure, cranes, forklifts. You'll see, and I'll touch on a case history in a bit, or case study in a bit, where some of the areas weren't all in place and there was some failures. Pre-planning, what's important? Practicality of use, ease and speed of deployment. How easy is it to use, you know, and how quick can I deploy it? The portability of it, that's more important around shorelines and beaches and land spills or river spills. You know, can I get it there safe? How can I get it there? You know, no point in that trying to get to a remote shoreline with a big boom reel that your trucks can't get to. Is it fit for the operating environment? Paul touched on this, you know, abrasions from things. If you're using a lighter boom around a tidal area on a jetty, it's going to rub up and down as the times come in. Compatibility with other equipment, always difficult from a response side to turn up. You know, the client may have, or the spiller may have their own equipment. We come with our equipment, or additional equipment's brought in, and it's not always compatible. Ideal world, of course, it would all be compatible and all the manufacturers would make the equipment so it all goes together. But we don't live in an ideal world, unfortunately. Living with a deployer, storage, again, is important, as you'll see. I'll touch on a bit more about in storage later on. Maintenance, can the maintenance be done by local teams? Do we have to send teams in? Can the maintenance be done during a spill? Is it easy to maintain? You know, boom repairs, how easy are they to repair? Does it have to be vulcanized? Therefore, it's a specialist repair. So there's lots of things to consider as all part of the pre-planning. You know, so as responders, we work with clients for contingency planning, adequate equipment. So getting that in. Safety in everything we do is the most important thing. You know, as responders, we want to go to the spill site, and I want everyone going home at the end of the day in the same kind of vein as they turned up in. I find the two pictures here quite disturbing, but it does happen. You know, there's a spill and there's a rush to get out there. So, you know, things as responders we should consider: the weight of it, the weight of the booms. You know, I think the UK's manual handling is 25 kilograms. But not everyone can lift 25 kilograms, and even those that can. Some of the areas you might have to go into, slippery surfaces from oil. Do you want to be carrying 25 kilograms? So it's a consideration. Noise, power packs, vessels, equipment going on are all noisy. Lifting arrangements, I'm going to touch on that in a bit, along with hydraulic lines. Here, working near water, as you can see, no one's got life jackets on. They were knee deep in oil with carcinogens. So for responders, having safe systems of work, standard operating procedures, all very critical to us, as well as trained and competent responders. So keeping your training up, your training skills up, not just relying on skilled responders coming in. And then in the event of a big spill, use of volunteers. They need to be trained. They need to be managed. They need to be overseen continually, so we don't get kind of the gun-ho approach where I'll go swimming out in oil and try and deploy a boom or do recovery. So weight, as I said, is important. It's an important consideration, especially around shorelines. Knowing the safe working loads for all equipment, and that being readily available on the boom, I think is an important element. A lot of the time you'll turn up and you don't know how much equipment weighs. You know, like I say, 25 kilograms is a manual handling standard in the UK. And look at the three guys here, a few guys here pulling that boom up there. That looks pretty heavy, dragging it up the slipway, probably damaging the boom at the same time, as well as probably, damaging themselves. Loading vessels. You know, you've got to know your point loadings of your vessels when you put boom reels on there or load equipment on it to make sure you're not making that vessel unstable. Great in calm waters. Landing craft don't tend to be the stablest of vessels anyway, so start getting a bit of chop or a bit of wave movement in there, then that vessel becomes very unstable. So I think there's a lot that as responders and as people like UK and Ireland Spill, we need to sort of bring in standards where we do know the weights, the safe working loads of equipment. Lifting. This has been one of my challenges over many years. Having certified lifting points on equipment. Now, for oil and gas industry, there's a big drive nowadays where our customers, clients want equipment in DNV containers up to the DNV 2.71 offshore container standards. And that's fine. Some of the reels, boom reels, don't fit into the standard size containers. So then you either have to get a modified reel or a modified container. But if you look at boom reels generally, it's often down to whoever's procuring, buying those reels to stipulate forklift pockets, lifting points. Lifting points generally aren't tested, stamped to a standard. Slings, yes, but the lifting points aren't. You know, I think in the bottom picture of the boom on the pallet, if you look closer, you can see a bit of kind of rebar or something welded there as a lifting point. It's, you know, I think we rely on, we'll lift this boom because it's an emergency. Yeah, but we also have to do it in training exercises and deployment. So getting a standard for lifting and testing, I think is a key element for where as UK and Ireland Spill we'd like to see things changing. And from a responder's point of view, I'd love to see that change, that lifting points on boom reels, skimmers, pumps are all stamped with a safe working load on them. I appreciate that it's probably difficult to test them to a standard, but knowing that would be of a major benefit. Paul touched on storage. Storage for booms is always has to be a consideration. You can see some of these foam filled booms, you know, 200, 400 meters of that boom takes up a lot of space in a warehouse. Therefore, a lot of the time it doesn't get stored in warehouses. It gets thrown out into the yard where it's stored. Containers are great. Shipping or storage containers are good, but you know, it depends again on the climate you're working in, the condition of the containers. They often get left to rot, and we'll find when we go out there to do maintenance or training that the equipment's not in such good condition. So, you know, I think that the awareness of not just response organisations, but companies buying oil spill equipment should be aware of their storage capabilities and what it really means. And rehab and maintenance, again, a consideration for responders. Field maintenance, it's not always easy to repair things on site. You don't always have the repair kits you need unless someone has stipulated it when they've brought the equipment to have spare parts in there. It's not there. For booms, very difficult to repair during a spill. So, you know, making sure that you've got an ability to jerry rig, fix things on site, important. And making sure, I guess, when equipment's supplied, that it comes with spare parts, that it can then be repaired. And when you use those spare parts, they are replenished. Rehab of equipment after a spill is very, very time consuming. Even after an incident, it's often after a training exercise, it's often time consuming. Bring the boom back. Imagine if you've done 400 meters of offshore boom, bring that back, wash it down with fresh water, check it all over, reel it back on the reels. Very time consuming. And then if it's been covered in oil, well, you know, you're never going to get that 100% effective. So that equipment is never going to be used in training exercises again. So it has to be segregated from other equipment, so you know not to use that. And I guess it would be interesting to have recommendations on effective rehabs, what industry standards are. Again, developing standards and recommendations. So this was touched on last week, setting standards on the skimmer ones. And Paul's touched on it. You know, I think he came out, I think his presentation, over 11 different types. Yes, there's ASTM standards. But, you know, as you saw, 18 different types of boom connectors alone. How do I get those to fit when I'm on site, unless I have joining plates for all of those ones? So should we have a standard of fittings for connectors? Should we use the ASTM ones or other ones? A big ask in an industry of this size, depending on, especially when they're internationally done. Hose maintenance and life cycles. Industry standards would talk about a 5-year life cycle of a hydraulic hose. NRC has an industrial services division with ultra high pressure and high pressure jetting units. Hoses are often changed every 5 years. But then if you look at a piece of oil spill equipment, it may have been run up once a month if it's lucky. You could go 5 years and that piece of equipment hasn't seen 5 years life, or that hydraulic hose hasn't seen 5 years worth of use. So should I replace that hydraulic hose after 5 years? Or should it be visual inspections? Because, you know, hydraulic hoses, when in continuous use, normally degrade from the outside, from the inside. The damage to the outside is normally caused through poor maintenances, poor storage, or, you know, incorrectly fitted, if you like, where they rub against another component in there. So I think it's an interesting one for us to look into as well, to talk about the setting of standards. What is a standard for hoses? Often we're asked when we ship equipment round, certificates of origin. Another one that we like to have that goes with equipment. Is there a standard for that? Should it be the manufacturer? Should it be the responders? Not sure. Design and certification of components. Always good to have all those design and certification of the components when you're trying to ship stuff overseas. And again, touching on build size and standards of offshore systems to fit in to 20-foot or 10-foot DNV, or normally the 10x8 DNV containers for deployment, so you can drop that straight onto the deck of a vessel. And you don't have to worry about getting dispensations for lifting an ISO container, or trying to find a spreader beam, or watching someone jerry rig a unit that lifting gear onto it that you don't want to see. Again, compatibility is an important thing. Hydraulic hose systems or hydraulic connections. There's, again, like boom connectors, there's a lot of different hydraulic connectors out there, and systems. So I think trying to get compatibility where we can and get standards would be a major step forward in the responders from a response side of things. So I wanted to kind of close out with a bit of a case study on a boom deployment. We were asked to look at with one of our clients overseas a failure of an offshore boom deployment. So basically, having looked at it, there were several things that went wrong. The boom, so it was the vessel crew had tried to deploy 250 meters of single inflation boom between two vessels. The picture you can see there is the large standby vessel that was deploying the boom. The towing vessel that you can't see in that picture wasn't really adequate for it. It was a jet boat, so it kind of skimmed across the water a little bit when it was trying to pull it into formation. But that picture's on once we'd shown them, really gone with the crew of a successful deployment. But initially it was an inexperienced team that tried to deploy the boom. The crew wanted to do it as part of a preparedness for a drilling campaign, rather than calling in a response team to do it. The boom, the initial boom, when we looked at the configurations of what they'd done, wasn't really fit, laid out on the back of the deck properly. You can see huge deck, but everything was put nearer the stern. The boom reel was span setted into a open top basket, and the span sets broke. The bulwark at the stern of the vessel, so as responders, ideal. We like a nice rolled stern we can just deploy the equipment off. Unfortunately, this one didn't have that. It had a bulwark at the back with pipe stanchions on it for storing pipes. So they tried to deploy the boom off the back of that during the deployment. The wind picked up, and unfortunately, the boom got stuck around the Azimopod thruster on the vessel. And that bottom sort of small picture is the remnants of the boom once they managed to get the divers down and cut it free. So we were called in to have a look at it and help them deploy that, repair the boom. Unfortunately, the section was unrepairable. That had to be cut out. But where the boom was deployed over the bulwark, there were also other damages to valves and patches in it. So we had to do a patch repair on site. There was no boom repair kit there. We found a local dive company who had some neoprene glue for us, and we went to the local garage and got some inner tubes, car tire inner tubes, to make an effective repair on it. It worked, wasn't ideal, but it worked. We also constructed a roller to go off the back of the vessel that would fit on the pipe stanchions and then allow the boom to be deployed and recovered over the stanchions, and setting the boom correctly in the DNV container by blocks and chains to hold it in there allowed for that to go. And also keeping an eye on the weather and making sure the vessel crews were trained, knew to turn with the wind, and really get it out there. And we did 2 deployments after that with a vessel crew of 200 meters, because the boom reel was down to 200 meters rather than 250 meters. And then we did another deployment where we put another 250 meters on it. So we in fact deployed 450 meters of boom for them. And the crew got competent into maneuvering the booms. So it doesn't always go well out there. You know, I was going to do a case study on a training exercise, but it doesn't always go that well. So it can fail, and it often does. So that's kind of me. I'm going to unshare my screen now and hand back to Mark.
Right, thanks very much indeed. And thank you to our 2 speakers. I'm just going to get my, yeah, there we are, I think. Good, so hopefully you can see my screen, that's great. I'd like to thank our 2 speakers, Paul Rayner from Vicoma and Mark Shepherd from NRC. And what I'd like to do now is to invite any questions. There has been one on recycling, and perhaps Paul, you could pick up on that. Are we thinking when we're manufacturing about how we will recycle the end product?
Thanks, Mark. So it's interesting that some tenders are now coming out with a view to life cycle costs. So how you're going to dispose of afterwards, particularly government organisations where they've perhaps have more time to write these things into tenders. I think the question was on disposal of a boom that hadn't actually been used in anger, I think it was. In which case, I mean, from my experience, one of the best things is actually to use that fabric as a sacrificial skirt for when you're deploying booms. So I've actually seen booms cut up and being put over the deck of a vessel or being put on the concrete slipway or the jetty. So they're actually using that to protect the boom while it's being deployed and recovered. A really good use of it. Also, if it's not oiled, so it hasn't been used in anger and been contaminated with hydrocarbon, you're not actually disposing of hazardous waste. And it really does depend on the type of material. So If you look at a lot of thermoplastics, there's certainly issues with burning because you've got to burn at incredibly high temperatures to get rid of the VOCs, etc. But there are still some options for landfill, for recycling. So some rubber products, for example, can actually be recycled. But certainly if it hasn't really been oiled or it's clean enough, actually using it for another part of the operation as a protective mat is a really good way of using boom fabric.
Great, well, that's great. Thanks very much. And I've got a question from Kirsty McKinney from BSEE, and the question's about shore ceiling booms. Where has this boom been deployed in the past operationally, and what are the recommended shoreline conditions for its deployment? Maximum tidal variances, wave configuration, and shoreline types. Mark, any comments on that?
It's been deployed in a lot of different locations, a lot of spills successfully. I've used it on spills in both the Erica spill in '99 around Belle Islands on beaches there. I've used it successfully for land spills for setting up containment barriers there in Kazakhstan on around some transition zones. So I think it's very widely used and very successful. Like I say, it's extremely effective and efficient on the flat, sandy beach, but it is also very good on pebbly, stony, rocky beaches because the water chambers will kind of adapt to the shore basically, and it'll mold itself to that. Maximum tidal variance, well, mainly you're bringing that right up to just below the low tide mark, right up beyond the high tide mark. So it'll then float, and then you're connecting probably a air tube and skirt boom to that as well. So they connect together, and then you take out 50, 100 meters of floating boom out as well. So they're effective on most shoreline types. Are
they vulnerable to larger waves?
Yeah, I mean, all booms are vulnerable to larger waves. These ones aren't really designed to float that much. They're there to seal the boom from when in that intertidal zone. So when the tide's coming in and out, we're protecting that and keeping it there. Obviously, they're normally worth something like 550 to 750 mil. So it depends on the boom you're connecting them up to.
Yeah. Kirsty, does that answer your question? And has anybody any other questions?
Mark, can you hear me?
I can indeed, John. Good afternoon.
Good afternoon. John Dawes of International Spill Accreditation. Just a thought, often when I was specifying booms in the past, I was able to suggest to the client that they specify which type of connector they had. And most boom manufacturers I found were prepared to put onto their booms whatever connector you actually asked for. So that the question of compatibility with other booms that were already held in the stockpile concerned didn't occur.
Yeah, no, I understand that, John. I mean, I've also done that myself, where we've made sure when we go to different manufacturers that we keep a standard. But as you can imagine, when you go to a spill, an NRC might be taking their equipment, OSRL, Briggs Marine, and if you've got a good shore or a good shore base where all the equipment's going to, and you've got someone that knows that when they're sending it out, the compatibilities of everything, it's great. But if I've got a boom reel, but we're running low on power packs, I've had a power pack failure, and the shore base sends me another boom reel and it doesn't connect, the hydraulic fittings are not correct, then we have this incompatibility. So yeah, companies would, I mean, as NRC, all of our hydraulic fittings are of one standard. I'm pretty sure OSRLs are probably all of one standard. But manufacturers do use different coupling or fittings unless you state which one you want.
Yeah.
think
Thanks,
to
Mark.
add to that as well, you know, from a manufacturer's point of view, we see the biggest issue when it comes to mutual aid. So like Mark has just said, they're about multiple agencies or companies working together. This is where it often goes wrong. So you'll get one company standardizing on a type of connector, boom connector, and another company standardizing on another, and they turn up to work together, and it just doesn't work. You know, so ASTM has definitely tried to cover this in the States, and you know, the concept is good, but it's how, you know, that standards can be rolled out universally, and still quite amazing domestically how many different countries will have their own variants, which they've decided is their standard.
In fact, I would say that within the Marine Working Group at UK and Ireland Spill Association, we are starting to work on looking at developing our standards and producing perhaps British standards, which will then hopefully ease some of those issues. So if there's no more questions, and I don't think there, I haven't seen any more come up on chat, I'd just like to thank Mark and Paul for their time and their comprehensive presentation. So thank you very much for that. I'd like to say that the next knowledge-based webinar is on absorbance, and that's going to be on the 24th of March, and that will be led by Darcy, and no doubt there'll be a run of responders wanting to assist in that, which is great. The next webinar that we'll be hosting will be at 1200 hours on the 24th of February, and that'll be in partnership with PolyEco, I'll be giving an update on the situation out there, and they'll be talking about the initial spill cleanup. And this, as I said before, will be the first of 2 webinars in which we're partnering with PolyEco to deliver them. So that's where we are. You can find more information on our website, www.ukspill.org, but keep watching that, because over the next month that will change and look really ritzy and glitzy and glamorous, and look in our new corporate style. But thank you very much for your time this afternoon. I hope we've answered many of the questions you've got, but hopefully in some way we've increased your knowledge, in which case the knowledge base has worked. This webinar will be edited, and it will go up online within the next 24 hours. So you'll get a link, you'll get an email with a link to it, and please do share it where you can. And that's the whole goal of that. So thank you very much indeed for listening today, and thank you very much for attending, and look out for more knowledge-based webinars. Thanks very much. Bye-bye.
Bye.
Thank you, Mark.
You're welcome. Thank you.
Thanks, Mark.